Yeah.
There we go. Sorry about that.
All right. All right, we've passed the main hurdle now, sharing the screen. Well, it's great to be back here in this department. I've been here a number of times and I have more connections in the department than probably anywhere else except Berkeley. So it's really fun to be back here and see lots of familiar faces that I haven't seen for a while, and really honored to have been invited by Andres to come and give a talk. I realized as he was introducing me that I should have sent him some fresh material because I think he found some of my older descriptions that I really need to update. So as he said, I've been at Berkeley for a long time. I am now trying on the label of emeritus and seeing how that fits. Spending my time working on taking the ideas that I've been working on the research side and through consulting practice into broader scaled use. By the way, should I be allowing people to enter the room?
No.
No, we'll handle that. Okay, good. Shared technology governance here. So what I want to talk about today is, under this broad theme that this series is about, is how urban problems that we all grapple with in one form or another, like housing affordability or reducing greenhouse gas emissions or trying to make cities more fair and accessible. They have a bundle of characteristics that are very problematic and difficult to find solutions for. They're complex and interdependent across sectors. They're chronic and persistent, but also subject to shocks like the pandemic. Things like housing affordability have been around for a very long time, but they took on a new twist over the last couple of years, I think we've all observed. And when they're so complex and intertwined, it's really hard to disentangle cause and effect. It's really hard to understand what is the impact of a particular contributing factor to measure that. And therefore, it becomes hard to design effective interventions. If you can't really isolate the effects of individual contributions or combinations of them, it's really hard to design effective interventions, especially in such a high dimensional space. There are so many different leverage points to take action. All of that makes it hard to assess benefits and costs. What course of action should we take in a particular problem? If we can't really evaluate the benefits and costs, it's really hard to tailor those decisions ex ante before we make them. And some of those investments are very costly and you can say irreversible. So the costs of getting it wrong are quite high. And even after we implement them, because of all this entanglement, it's very hard to evaluate their effectiveness. I'll give one example, drawing from Toronto. The Shepherd Line, which was built in the north of Toronto, on which sits the Bessarion station, had grand ambitions, and it was an expensive project. Several downtown style developments around these stations. And yet, to single out the Bessarion station as a particular case in point, it performed very, very poorly. Third worst performing transit station in the entire system. And looking backwards to the 20 years that have passed since it was built, it's easy to start second guessing, why did this emerge as an outcome? And it has a lot to do with this lack of coordination between the urban development around the station and the investment in transit there. There was a tremendous amount of single family use zoning surrounding the station. And I'm sure we can all find many examples like this. But the point being that such an expensive decision should be evaluated well ahead of time with well-coordinated tools that allow us to analyze those impacts. But it's extremely challenging. Now, we represent a lot of different fields, and I want to commend those of you involved in the urban science program here for really being at the forefront of doing exactly what I'll be advocating. So I'll be preaching to the choir a bit in this talk. But we come from a lot of different disciplines, and we all have the theoretical frameworks that we were trained in. We have the tools and methods, the software, all the things that we use to pursue the practice of that field. And we don't talk to each other enough. in general. We work in silos. We were having a conversation just before the talk about how the incentive structure in academia for faculty to publish is very, very focused on publishing in your own field and primary innovations that are at the cutting edge of that field. It penalizes collaboration across disciplines. I've worked with computer scientists for many years, and we've always found it difficult to find ways to have the computer scientists be able to publish in their field for work that is as applied as we were doing. It's easier to build a curriculum that brings students together, and I think you've done a really commendable job of that here, but I wonder if you've solved the incentive structure for doing the research, which is a harder nut to crack. If you have, I'd love to hear how you've done it. So this is a very old cartoon, and all of you have probably seen variations of this. I've seen attributions back to the 13th century. The parables about this probably didn't have streetlights back then, but same concept. That we all tend to look for solutions in the space where we're familiar, we're comfortable. We've got the tools that are illuminating a particular space for us, and we work within that space. We work within our comfort zone. To single out planning and design, and I'll bring artificial intelligence into the picture, since I know that's going to be a big part of what's happening here in urban science. Perhaps we've got a little bit of the streetlight bias in these disciplines as well, each of us trained in our own ways. And I'll cite MIT Technology Review here for a little parable, perhaps, about Toronto killing the smart city forever after the Sidewalk Labs experience there. We do a lot of work in Toronto, so we get to hear a lot of the second guessing that the city has about, how should we use technology in ways that are maybe better grounded in the things that people in this department would be very empathetic to. People that study planning, people that study urban design, that have the deep connection to these disciplines, they have a human intelligence that needs to be fused with that artificial intelligence. And that's really the main label of the talk that I was trying to pull together. So the thing that I've been working on for years and that I've started pursuing through now a more commercial opportunity is to try to create a transformational potential by building a platform that combines the tools and perspectives of AI and planning and design, pulling them together so that they become more interoperable. They become a kit of parts in some sense. But to use the streetlight example, maybe we start getting some illumination across the boundaries of these disciplines and start learning from each other and enable collaboration, both in practice and perhaps in research. I also think that some of the same thing happens as people work across different scales. Some of the problems that we deal with on a more local level play out a bit differently at a higher scale, at a neighborhood level, at a municipal level, at a metropolitan level, and so forth. And so we need ways to, I think, work together and collaborate across these particular silos. Now, I'm going to return to our humble planner and raise some questions from their perspective as they're trying to get their job done, and then return to grounding these ideas a bit more. So if you talk to practicing planners, you're often going to find out that they're trying to address a variety of questions like how much housing they can physically support with the current land use plan. What would it take to make it more financially feasible for developers to build there? How might a new transit line change the balance of jobs to housing in a particular scale of the city? Where is growth most likely to be happening? How could changing land use help with affordability and equity goals? All the interaction between different goals. How will new mandates from the state? I've lived in California for a long time, and there are lots of mandates coming from the state. The regional housing needs allocation process being a significant one to try to make sure that housing affordability gets packaged into the planning process. And how do we support this with data and the kind of analysis that's needed, often with very limited resources? So I'm going to focus on three parts of the analysis that are needed to often answer a variety of those questions. And we'll probe that in a little bit of analytical detail as we go through here. So we'll start with an individual site. The planner is asked, what's the development capacity of a site? Maybe the city wants to build affordable housing on it, for example. So regulatory housing capacity is what we're looking at here. We're looking at the buildable envelope or the amount of housing that could be built, just looking at the parcel size and shape and looking at the zoning and looking at how those two things interact to generate a maximum building that's compliant with the zoning and compatible with the site itself. Now, often you'd want to look at the surrounding context as well to make sure that it's compatible with the surrounding neighborhood. But just focusing on the site itself leads us to this kind of envelope analysis. And there's a lot of tools out there. Architects are typically the ones that are doing this analysis. Test fit type of analysis is what some people refer to it as. And we're really just trying to figure out what can I build here? Or if I have a building program in mind, is it compatible with the site? All right. So this is just an example of what that might look like. There's a site selected here, and then we're looking at what kind of building massing and what kind of unit count might that generate on that site. So this particular set of images happens to come from one of the tools that we built, but there are lots of other tools out there that do some of this kind of work and perhaps do it in different ways. So often what's involved in these is some form of procedural model or parametric modeling. And the architecture field and 3D modeling have come a long way in our capacity to do that. So there are a variety of platforms that support that. Some of them go in the direction of saying they generate many, many options, perhaps using AI to proliferate the number of options, and then allowing the user to filter the options to some subset that they might want to work with more. But it's a little harder problem to really maximize or optimize a site to its highest and best use, especially when you start considering other things, as we'll do now. But first, if you ask the same question at a different scale, the problem transforms a little bit. All right, so now let's say the city planner is being asked, what's the development capacity of this neighborhood? Or what's the development capacity of my city now that I've just changed the zoning plan for it? How much did that change what's feasible physically and under the regulations to build? So now automation is critical, right? We can't do that in SketchUp. We can't do that manually. We have to do it with some sort of automated process. And this is where procedural modeling tools are going to be, generative tools are going to be particularly valuable from a computational perspective. But optimizing across a whole city, that's a challenge. And also some other little problems start to come into the picture here, like the market. So now let's say the question modifies just a little bit, and we're being asked as a planner, what is development capacity if we consider market viability? All right, so we could consider that at the site level first, but then it becomes again a more complex question as we change scale. But let's say we look all the way to the left and we're back to at the top left, we're looking at the parcel size and shape, we're looking at zoning, trying to figure out that buildable envelope. But the zoning codes are also looking, giving us an insight into the supply of buildable sites. That's going to be important. And then a lot of factors are going to influence cost of development. And our zoning is also going to influence a little thing called entitlement value, right? We upzone around transit, suddenly that land becomes a lot more valuable. The property owners know that. They're going to command a higher price when they sell. And suddenly you may get a different style of development and different cost of development around that transit than you thought you would. So a variety of other factors, macro factors, labor, materials are going to influence cost of development. And then some other policies like inclusionary zoning, development impact fees, subsidies perhaps of some types. You might be looking at density bonuses, you might be looking at reducing parking requirements. All those factors are going to influence the financial viability, which we typically measure through a pro forma. So now it's not the architect doing the work like up in the building envelope. Now it's a finance person, somebody that knows numbers, knows discounted cash flow analysis. Those two are not typically the same person, right? They have a different training, a different skill set, different toolkit. This person over here doing the pro forma is used to doing their work in Excel, right? As opposed to working in SketchUp or Revit or something else up there. All right, so now we've got a combinatorial problem that we have to solve around the financial analysis for the project and all these inputs possibly varying, and the zoning and the site itself. And then there's also an expected market price for the project. So now that's what I would do on a single site, and we'll show an example of that in just a second. But what happens if I need to aggregate across a whole bunch of sites? Right? And I can do the mechanical thing and I can aggregate them up. But let's say that I'm doing a Los Angeles wide or a San Francisco wide or a Boston wide zoning change. And I want to look at market viability of those projects. You can anticipate this is going to be a problem, right? Because things like this might be impacted. Right? There are feedback loops. How do the projects get absorbed into the market is going to feed back into the pro formas of the projects that follow, right? So there's a dynamic temporally and spatially, and if you have a local supply shock that's significant, it's going to slow down the advance of other projects in that immediate local market. And this thing scales up from that point. So let's look at a quick case study just to step through it. And I realize I'm going to have to zoom through these because I'm going to obliterate the 20-minute recommendation of the talk if I don't. So let's look at a particular case study in on 140 Merton Street in Toronto. This was a site that the city was able to put onto the market for affordable housing, and they're trying to facilitate a process to get the most units built on that site to help ease the massive shortage of housing in this area. And so they started a process to go through citizen review and input onto the process and modify it. So they ended up with 180 senior-oriented units on this site. And so now what we want to do in a context like this is be able to explore the trade-offs between making all those inputs change, whether we're changing the zoning, the height, the setbacks, the parking requirements, and so forth, or the building program. Are we doing mostly smaller units, or are we having to include some family units in this site? What's the target unit mix, and so forth? And then ultimately, we have to look at the return on cost. We'll have to look at the profitability, the market viability. So I'm just going to screen through these really quickly to show some different examples with changing the unit count and the permitted height and the setbacks, increasing the height, but now we've got a really boxy, bulky building that's not going to pass community feedback. So we modify the bulk requirements to let some daylight down to the street and so forth. That's the kind of interactive work that allows, say, a planner to close the loop a little bit between the work that the architect would typically do on test fit and the finance person would do on the pro forma. So let's go back to the city planner. Now they're being asked a harder problem. They're being challenged about that growth and build out analysis. And now people are asking, well, what's actually likely to come to the market? How much housing supply are we likely to get if we make these zoning changes? Is it going to move the needle on housing affordability, for example? Is a question that comes up in many expensive cities on both coasts and in Canada as well. Now the problem got a lot harder and my flowchart got a lot messier. So now we're encompassing a whole section down here that is about transportation infrastructure and quality of service and how that's influencing demand for locations. How households and employers are changing over time and how they generate demand for buildings. And we have to worry about absorption of existing buildings and new buildings and how they're competing with each other. So we have to be monitoring existing development, projects in the pipeline, and so forth. And all of that needs to go back into not only just the build decision for a site, but also the feedback loop. So now we have a much thornier problem. And this is the space that I've been working in for a long time with urban modeling. So variations of this slide will be familiar to a few of you that have been around UrbanSIM for a while. But the basic idea here is that we're modeling both the non-residential and the residential side of the market, and not just the supply side, but also the demand side of the market, which is really critical to getting a more complete picture, especially as the scale goes up. So how do these models work? Really, we're talking about a term called microsimulation, agents making decisions like relocating, whether to rent or own, what type of housing, what location. And the problem is that these are interdependent. The choices are interdependent, not only within the individual household, but across households. And they're also interdependent with what the supply side of the market is doing, where developers are building, how zoning is changing to permit it. So what we've been working on, I've been doing this kind of modeling for quite a long time. It's always been hard. It's always been hard because data was challenging to assimilate. It's always been hard because you can build individual components of models, but getting them all to work well and harmonize well together and predict well over time is a particularly important challenge. A couple of people in this room would know something about this at MAPC, who we're working with to make these models operational, not only here in the Boston area, but across the state. So we've been working on some recent innovations, drawing in AI more directly into the work we're doing, not replacing the models with an AI black box, because none of our users would be satisfied with that. They need to be able to analyze the impacts of alternative courses of action, changes in zoning policy, changes in transport investments. And a black box type of predictive model, even if it predicts really well on observed data and test data, is not going to satisfy all those requirements. So what we've done is taken AI techniques and coupled them with our modeling work to preserve the behavioral parts of the modeling and its interpretability and its explainability. You can even look at individual parameter values and standard errors if you're into that sort of thing. But you can also essentially tune the entire model system to work together and achieve very high performance over a long period of time. So we're using 10-year windows to do that work. And we're embedding that into a new platform that does the things that I talked about, that estimates development capacity parcel by parcel, streamlines some of the recurring processes and automates them, assesses policy challenges and enables users to design effective interventions, and facilitates communication about the impacts of zoning and other regulations, and facilitates data exchange and searching for solutions that also achieve other goals, diversity, inclusion, and livability, for example. So our ambition here is really to help urban planners and other disciplines, I'm not leaving them out, to experiment with land use and transportation policies to see how they might impact the neighborhood, a city, or a region over time. And we contrast it sharply from scenario planning, which is really valuable and important to just explore uncertainty and make some assumptions and evaluate what the impacts would be. Here we're trying to enable rapid modeling with data and empirical validity to do that. So we're doing quite a bit to build in data, making it easier for users to get started, assimilating all the relevant data to begin with, and letting them replace or override with local data. A lot of built-in analytics to explore existing conditions, and then using those that insight gained about existing conditions, begin to design interventions, begin to design upzoning, and do this in a much more user-friendly way than what we've been able to do in the past. And then comparing key performance indicators. This is ultimately what people are going to be concerned about, are the indicators. And what we're hoping to do as we move forward with this work is not only use the AI techniques as we're currently doing to tune the models and make them perform better and predict better, but also to essentially reverse engineer what bundles of interventions might help us accomplish the outcomes we're looking for. And not do that in the sense of providing an answer, but more in the sense of providing a toolkit to enable rapid exploration of a very complicated design space. There are so many different combinations that if we manually explore this design space by creating scenarios, as we're talking about here, it could take forever to really find sweet spots where the trade-offs are ones that are attractive to the community. And we need to be able to explain how the model is performing to different degrees of scientific to more lay audiences. Some will want to know a lot about the technology and the standard errors and parameters and so forth, and some will want some reassurance that it's doing the right thing, that it's predicting well. Some people overtrust information coming out of a computer. We want to make sure that bias isn't there as well. So to close, we're really just reaffirming the, I think, path that you're taking here with the Urban Science program, that there is a lot to be gained by fusing these multiple disciplines together and learning from each other, and bundling access to the technologies and tools in ways that enable us to all work together more collaboratively to solve some of these very vexing problems. So with that, I'll close, and we'll happily take your questions. Thank you.
Fantastic. This is really great work, and many of us have seen the work over so many years, and it's super interesting to see where it's actually going next. I just wanted to open with one lead questions and then go to audience questions that may come up. And this lead question has to do with what you brought up at the very end, the sort of reverse engineering world, where you could truly enter the discussion of projective or normative planning and design, and then sort of build analytics and performance right into it. Can you tell us a little bit more about that? This has been an area that a lot of people have speculated about historically, and then oftentimes runs into certain very difficult challenges too. For instance, the fact that the same performance outcome can be achieved by a million different configurations. So what becomes the role of the design decisions and simulation to configure one solution that gets the performance indicators versus the other 999,000 alternatives? And so what are the challenges of moving in that direction? What do you see as the upcoming issues?
There's no shortage of challenges, technical and in every other dimension. At this point, I just want to hint in this direction rather than to say it's a completely solved problem. I won't want to make such an egregious claim, but we see a lot of potential for moving in this direction. And with some former collaborators, we've done work where we've taken procedural modeling, which is forward modeling, and then added a layer of inverse procedural modeling, which is working backwards from the objectives, whether it's preserving sight lines to landmarks or other factors. So there is definitely work to build on. And I'll just say, without saying too much detail, that the strategy that we've been taking with the modeling in this recent work that I've just described is one that appears to be very amenable to that approach. It is one that, provided that we can, shall I say, structure the inputs in a way that is similar to the model tuning process, but instead of tuning the models, we're tuning the inputs to the models. And the thing that we're tuning it to maximize is the fit to a certain set of objectives that are specified by the user. Now, running computer models has historically been, transportation models have taken a long time to run. Land use models have gotten a little faster. But if we were able to run a 10-year simulation in, say, a minute or less that was doing all of this, or tune the model system in just a couple of minutes to fit the longitudinal data, it starts to open up the possibility that we can wrap that same technology around optimizing for objectives. So I would say at this point, it's a potential. It's a very attractive potential because it has so much usage value. And I think it draws back in the human dimensions of this in a very interesting new way. So rather than saying, here, we're going to have the computer crank out an optimal solution for you, we're going to let you instead interact as you experiment with framing your objectives and the trade-offs between them differently, and see what kinds of spaces that generates in terms of outcomes. Because I think in all of these cases, these are contentious spaces. There are lots of different stakeholders with different value functions they're trying to optimize. They're looking for different things, different goals. And so there is no optimum, period. What we're looking for are ways of searching a design space for valuable, let's say, Pareto advancing alternatives that increase benefits without decreasing them, increasing benefits to some without decreasing them to others. So that's the general strategy. And,
that's great.
Maybe
and since it takes a couple of years to build these models, Moore's law will have solved the computation by the time they're ready, and we can actually, let's open it up. Yeah, Aziz. Please do speak to the microphone so the online audience can also hear the question.
Hi, Aziz Hassan, PhD in computational sciences. What I wanted to ask is, these types of models are really complex, and sometimes even with perfect knowledge of the past, perfect data, there is a really tough assumption to be made about trust and uncertainty in the future. Like, how do you handle certainty of price elasticity subject to zoning changes and so on? That'll kind of trickle down and convolute with all sorts of uncertainties. Like, I just want to hear your thoughts about the.
Yeah, no, I appreciate the question. And I probably should have addressed it proactively instead of waiting for the question, but I appreciate the question. So I think with the advances that we're now making computationally to be able to do this sort of training, not in the semi-manual way that we've done in the past, it opens up the possibility of, first of all, exploring longitudinal tuning, as we're now doing, and perturbing systematically all of the inputs and doing sensitivity analysis to quantify the uncertainty. But I think I'm going to take your question to a follow-on that you might ask, which is, let's say that we tune the model for one region, let's say for the Boston region. And there are aspects that have not been experienced here in the Boston region that have been experienced in other places. This would be more relevant, let's say, for a smaller community that's less diverse. If we can build strength into the model in kind of a multi-level modeling strategy, drawing information content from other places that are similar in some ways and diverse and different in other ways, it gives more information content to be able to generate predictions that are plausible in this. So that's one part of the answer I would give. The other is, instead of doing modeling as a very cumbersome once every 5 years or 10 years process, what if we were really fusing monitoring and modeling updates as a continuous feedback loop, so that as we're generating new waves of data and observing what the model is predicting, we enter a pandemic and the world suddenly changes, right? We have to monitor what's happening. How are our predictions missing the mark? How can the model be retuned quickly to adapt to what's changing and not overly extrapolate? So there are all kinds of interesting questions about overfitting and avoiding that outcome, so that we can generalize the model to predict under different circumstances fairly quickly. It's a complicated and loaded question, but I appreciate it. Yeah, that's a good one. Yes.
This is like a weird question, but
I like weird questions.
okay.
I noticed you're looking at building materials is one of the things.
One of the inputs, the cost.
One of the inputs.
Yeah, construction cost.
Given climate change, which seems to be happening more rapidly than anyone predicted, some years ago, it seems very hard to predict where there might be material shortages, or there might be, you know, lack of grain from the Ukraine, or, you know, who would have predicted that, you know, 5 years ago, et cetera. So I'm just wondering how you think about that, because it just seems like we're in a period of such instability. It's
Totally.
really hard.
Yeah, no, that's also a wonderful question. So, you know, I'm not going to say we have answers to all of these questions. They are fundamentally hard. Things like construction costs. We started working on this particular part of it in our collaboration with the Canada Mortgage and Housing Corporation, which, you know, does a lot of macro-prudential policy, and they're trying to meet Canadian housing affordability goals. And we started enriching part of the model that deals with housing construction and the costs and interest rates and how they affect construction. Obviously, that's a moving target right now as well. And so while we would not have ever claimed to predict the pandemic or the consequences of the pandemic on supply chain issues and on the cost of raw materials, I think it's fair to say if you instrument the inputs to the model appropriately, it should open the door to being able to experiment with scenarios in which you do shock construction costs and have it run through the rest of the model system to understand, given what we do and don't understand about how the market works, what are the likely implications of that? How is it likely to change the nature of housing that gets built and its cost? Do we treat it at this point as a much higher cost input and therefore substitute away from that factor towards other factors? And if so, what does that look like? So I think the construction cost is tip of the iceberg. To your question, there are so many other levels of uncertain inputs. And I would say what we want to try to do with these models is make those inputs experimentable. So you can modify them and evaluate the impacts as much as possible. So scenario planning and scenario modeling, I see really coming together in an interesting fusion. Yes.
Hi, Paul Ronick. So I think both the previous questions were about the world changing and how do we think of that. So my question builds on that. It's about people changing over time. So when we think about predicting 10 years into the future, how do we think about changing preferences, changing behavior, more on the demand side?
Yeah, no, that's, I knew I would get a battery of really good questions here, which is one of the reasons I like coming here. So that's probably, I won't say it's the hardest one yet, but it's right up there. Trying to understand how behavioral preferences are changing. Well, trying to understand behavioral preferences to begin with is hard, and understanding trade-offs. And so we've got all of the great work on discrete choice modeling to build on to try to analyze trade-offs that people make. We can try to present novel choice situations with stated preference surveys and the like, as much of a fan or not as you might be of those. But the much harder problem is trying to understand how changes are happening over time to those preferences. And I think preferences are really hard to understand as an abstract concept. Preferences are contextual. That is, we're making choices. You hear something like, people want a single family house with a large lot and great schools. Well, of course they do. If it's priced attractively, and if they don't have to pay for the external costs of that, then yes, they would make that trade-off. A lot of people would, not everyone, of course. And so preferences change from context to context is one way to think about this. And they may change more fundamentally over time. I mean, as we experience climate change, as we experience recession or more serious economic disruption, preferences may change more fundamentally. And so I would go back to the topic that the comment that I made a few minutes ago about needing to couple monitoring with model updating. I would take it in a more Bayesian framework of thinking that we need to have ways to update the models with what we're learning over time and get away from having parameter values that are rigid and static for 30 years of forecasting or planning. But if you have great suggestions on how to accomplish the answer to your question, I'm all ears.
Thank you,
So-
Professor Waddell. We'll actually take a question from our online audience. Emily, would you like to unmute yourself and ask your question?
Sure. Hey, Paul, Emily Talon here. It's been a while.
Hi, Emily.
Hey, at one point you had a slide up that said something about whether or not zoning change was capable of moving the needle on affordable housing. And that's just such an incredibly great question. And I just wondered if that is something UrbanSIM tackles and whether or not there was an example of doing that kind of analysis.
Yeah, Emily, thanks for that question. Really appreciate it. So, I mentioned the Canada Mortgage and Housing Corporation that we're working with closely, and that's really the motivation they have for getting involved with us, is to be able to start exploring whether land use regulations, including zoning, of course, but also things like developer impact fees, were in some ways throttling the market and reducing the supply response to what was a tremendous amount of pent-up demand in the Toronto region, Greater Golden Horseshoe, and in the Vancouver region in particular. And so we did start digging into that, both at the site scale with the work we've been doing with Penciler and being able to experiment with how zoning impacts what's feasible to build, given the land costs and given the construction costs, given the market rents and prices, and whether or not there's inclusionary zoning and so forth. And so that makes it practical on a site-by-site basis. But they also wanted us to be able to explore that on districts, such as the Golden Mile district, or around various transit lines that were being extended in various ways, and also middle housing through a lot of Toronto. There's a tremendous amount of single family and single family zoned neighborhoods that there are some discussions underway about at least considering what the impact is of having such restrictions on housing supply and how it creates side effects. So we are deeply engaged in it, and we've been doing case studies on this in that context. And we'll continue to try to refine our capacity to answer the questions in a satisfying way.
We can share cases.
Yeah, right.
Running, Joe.
Yeah, hi, Paul. You've been doing urban modeling and urban analytics for quite a while in academic setting, with having to raise funding from NSF to sort of build models that are tried and true, to trying to see what is saleable from a business point of view to actually help real planning at a time when the sort of computational capability and the data has changed quite a bit. I just wondered if you could comment a little bit on the difference in perspective as you start this as an academic and as you try and make it viable as an ongoing activity over this time period.
So I love that question. And I'm going to refer to my co-author on this, Arazu, on this, because she often will ask me a similar kind of question. Coming out of academia, the incentive structure is to publish innovative research. And in an applied discipline like planning, there is additional value. There are bonus points for doing things that make an impact in the real world. But that's less true as you get across the campus to other units. Applied work is often seen as somewhat of a second-class citizen in computer science, let's say. Even though a lot of computer scientists will go and start up companies to take that work out into the real world and do pretty well at it. So I've always liked that boundary line between doing pioneering academic work and seeing if it actually matters to anyone in the real world. And I think the perspective change from looking at this as an academic, switching hats and doing it as someone who's trying to create a viable entity commercially, is that you end up having to pay a lot more attention to what problems people have that you need to actually solve. And it's not quite the same weight that you place in academia. When you're thinking about publishing that next paper, it's all the weight goes on what is a really important problem that a fair number of people have. And with the research work that we've done, we can turn into a practical, scalable solution. Modeling and scalable are two words that you would never see associated in the same sentence, generally. Modeling is a labor of love and sweat and tears and years. Typically, in most of my career, it was that way. And now we're starting to take on customers like the city of Brisbane, who solicited for an urban growth modeling SaaS platform. So it is becoming productized to the point that, love the background, that we are seeing commercial value in it and opportunities to turn it into a platform that can be used in practical ways. But it means paying a lot more attention to some of those planner problems that I mentioned and the pain points that they experience. Got time for another?
No, I just want to say that's actually an ongoing challenge in the company between Paul and me, that he finds very interesting research questions and he really wants to tackle. And I'm like, we have limited resources. Our customers sitting here, they're having problems. So let's focus on those. But
there's a bit of a tug of war between
we
solving
do
that
have
really
a little bit
interesting.
tug of war, but no, actually, I think we're making a balance.
I think you've got a question too.
Yeah, thanks. My name is Bruce Hecht. Ted Halsey is an architect in Denver's on the call. So we've been interested in how people get involved in decision making and how models can be used, particularly for transit and land use. So I was intrigued what you mentioned about how experts from different areas can use the models to generate possible examples. But then you also did the wake up word, which was, experts, but also lay people or civic engagement.
Yeah.
So I was curious to know, can you say more about where's the opportunity and what's the open questions about that kind of involvement?
Great. No, I appreciate that. So I'll refer back first to an experience we had working in the San Francisco Bay Area with the Metropolitan Transportation Commission there and their Plan Bay Area process. This was a kind of a new planning process that emerged out of new state mandates in California, which California has many of. And it required a certain degree of outreach to the communities as they formulated the plan and wanted to do engagement. And we were doing quite a bit of work at the time with 3D visualization of the simulation results. So we got involved in that process and in the civic engagement. So there's kind of two parts of this story. One is the success story and one is not. The success story was that as part of the planning process, the models were, the Bay Area in California is a very contentious and litigious state. There were lots of lawsuits typically every time there was a regional transportation plan done, brought generally by environmental groups for highway projects and the like. And so they started to put the land use model and the transportation model in the middle of this public debate around different strategies, different directions the plan should go, which is kind of a dangerous thing to do. But during the process, we found that as advocates were coming in with different ideas for what to do, we were able to encourage MTC to use the modeling as a way to create an avenue for input. And so different advocacy groups coalesced into a couple of groups and were able to formulate different scenario inputs. And those were run through the same model system and the same KPIs, same indicators produced. So to create a level playing field with the favored alternatives that MTC was developing with the Association of Bay Area Governments. That's a bit of a success story. The one that isn't is the other side of that, taking the visualization out into the field, into large public meetings in auditoriums, and trying to get people to engage. This was right at the peak of the Tea Party, which still has some resonance today, even though not in those words. But they had an organized group come and totally destroy the meetings and make them, inoperable. And it was very skilled at disrupting public engagement. So that was the failure part. The final point on this, and I know we're running out of time, is that I think with the speed of interactivity and the kind of ease of use that we're generating now, we think that we can start to use this in workshops that involve citizens, involve other stakeholders, sort of on an as desired basis. So I'm not pushing this on anyone, but that it starts to open up the possibility for replacing assumption-based workshops with more modeling of scenarios, but do it quickly enough to get interesting results.
I have a success story if you want me to tell.
Go.
So there was, you showed a Merton site example in Toronto. There was another parking lot in City of Toronto that City Council wanted to build affordable housing. It was empty lot and unused. And after 2 years, by the way, it took them 2 years to come up with unit mix and unit program and building massing, and to post to the public that this is what we are going to build here. And a group of housing advocates, they're called Housing Now Toronto. They reached out to us and said, we think City Council can do better. Like they're proposing here, let's say, I don't remember exact name, but like 100 units building on this parking lot. And they said like, there's more potential. City can do better. And they applied our tool. And I promise, Paul, I don't want to be a marketing person here, but in 2 hours, 3 hours, they experimented with lots of options that they could take to the City Council and show you can build taller, but still not exceed the regulation, and still it would pencil out for developers to build. And the plan approved, and now they are building, I think 100 more affordable housing on that lot. And I give credit to that housing group of advocates that really pushed for it. So they went to the council with data and with analysis that it's possible. So I think that was a story.
So
Great.
I think we're probably out of time.
We are out of time. Thank you so much. Really appreciate it. Just a quick announcement for next week. Next Monday, the next talk will be back on Zoom. It will be Ellen Dunham-Jones, who will be talking about retrofitting suburbia. So we will back to cyberspace for the next few weeks. And Paul will be around and there is Zoom for a few minutes if anybody wants to follow up with anything.